Hi guys, so in this video I would like to demonstrate how to do the image classification using CNN. CNN stands for Convolutional Neural Networks. So before that, you must be having a basic knowledge of deep learning. So deep learning means you'll be having deep layers. So your data is processed through sequence of layers, and finally you can have an output with good you know um, good accuracy. So CNNs are one of the popular network for image classification in deep learning, and these can process images and also videos. So when you have videos must be converted into images, and then you can process those images using a convolutional neural network. So what happens in CNN is when you have some image like this input, so this is the input image, and from this image the features are extracted, and those features are called as feature maps. That means from an input image you'll be having a set of features, and these features goes through sequence of layers, and finally you can have an output. So let us understand a bit in deeper level. So when you have an image, like for example this is the image for digit 8, and when you look at this image, so the image is represented as pixel values, nothing but the color values in the range of 0 to 255. So 0 represents the black color, and 255 represents the white color, and the combination of RGB, red, green, blue, defines some color, nothing but the pixel values. So if you look at this image 8, so these are the pixel values like 462, 142, 146, and some other areas, in some other areas you have zeros, means there is no information. So if there is a information, then that can be represented with the pixel values, otherwise 0. So what are the important components of a convolutional neural network? So there are three layers. The first layer is convolutional layer, and second is pooling layer, and the third layer is fully connected layer. Then what do you mean by convolutional layer? Convolutional layer. So when we have a data, when you have an image, so from that image you will be extracting the pixels, and those pixel values are given as input to the convolutional layer, and convolutional layer will give you the feature maps. Understand? So here we say the filters are nothing but the neurons which contain some information, right, which contain some information. And from the image you will be having set of feature maps, nothing but the features go through sequence of layers, and the output of one layer is given as input to the next layer. So you can multiply the number of filters, means you can have as many filters as you want. And similar to the machine learning, deep learning is also uh, based on the trial and error approach. So you can build an architecture, and with that architecture, if you are getting proper results or proper accuracy, then you can stick with that. Otherwise you need to change the architecture or neural network structure, so that you'll be having a good model. So we'll understand that in deep layers. So the input to the convolutional layer is image, and the output of convolutional layer is feature maps, and these feature maps are given as input to the pooling layer. So the role of pooling layer is downsampling the image. So the image can be downsampled, or you can reduce the dimension of the image so that you can understand or process in better way. The third layer is a fully connected layer. By applying the activation function, this fully connected layer will give you the output. So let's understand in a bit deeper level. So when you have an image, let's say the shape of the image is 32 by 32 by 1. It means 32 pixels width and 32 pixels height, and here 1 represents the number of layers. So if your image is black and white, then the depth of the layer, or depth of the layer is 1. Understand? And if the image is colored, then you can represent that image as 32 by 32 by 3. So 32 means the width, the number of pixels defining the width, and height 32 pixels over here multiplied by the number of channels. So the colored image is represented using the RGB format, red, green, blue combinations. So 3 layers are there. So that is the shape of your data. And if you give the image as input to the convolutional layer, then it will give you the intermediate output, that is nothing but the feature maps. Let's say this is your image 32 by 32 by 3, and from this you can have a small filter. So you can consider this as a part of the image which can be processed further. So the shape of this filter is 5 by 5 by 3. Okay, 5 by 5 by 3. Then this is processed in sequence, and finally you will be getting the intermediate output like 28 by 28 by 1. So how do you get this 28 by 28 by 1? So for that there is a formula. The formula is this one: output size is equals to n, means the number of pixels totally used, 32 minus filter value, the filter shape is 5, so 32 minus 5, 27, divided by s means stride value. Okay, s means stride value. So you can understand the stride value from this figure. So for example, if your shape is 3 by 3, means from the original image you are taking a part and the size of the part is 3 by 3, and once you process this part, then we'll be having some intermediate output. Okay, then again you move one position to the right side. That means how many positions are moved? Only one. In that case we can say stride value 1. So the information is captured from here. Again you move the filter, then the information is captured, the again moving one position, so the information is captured. Like this it is continued, and you'll be having each and every pixel value of the original image. So 27 divided by s, which is 1. So 27 by 1 is 1 plus 1, which is nothing but 28. So the intermediate output you got over here is 28 by 28 by 1. The number of layers you can consider as 3 or 1. So which defines colored or black and white. So this is the output from the convolutional layer. Your input is given, then from that input the pixel values are processed, then you'll be having a set of feature maps, and you can have so many filters, like 10 filters here. That means with each filter you'll be having the intermediate output. Then I hope you from this you understand what is the input to the convolutional layer and what is the output of the convolutional layer. And then the second layer is pooling layer. So pooling layer downsample the image, right? For example, when you have an image, the image can be processed in the next level, and you reduce the information. For example, here there are two types of pooling layer: max pooling and min pooling. Max pooling is by default, and which gives the maximum information. Let's say this is your part, this is your 2 by 2 filter. So from this 2 by 2 filter, what is the maximum value? The maximum value is 8. Again from this part 2318, max is 1. Then 0125, max is 5. Then 0010, the max is 1. So the output of the pooling layer is this. And min pool is very rarely used, because we always want the maximum information from the input image. Then finally we'll be having the fully connected layer. So this layer applies some activation function, and then it produces the output. For example, if your objective is to classify an image, then the images are classified. Okay, so these are the 3 layers of convolutional neural network. So you need to remember, and you need to define these layers when you define a model. So let's take an example how the classification model is built using the convolutional neural networks. So here MNIST is one of the very famous and important data sets. So whenever you are learning deep learning, so you must be knowing what is MNIST. So basically it is a handwritten digits data, and handwritten digits, when you say digits, so the total digits are in the range of 0 to 9. That means 10 digits are there totally. 10 classes, better we say 10 classes, 0 to 9. And in this data set we totally have 60,000 images. We totally have 60,000 images, and from this 60,000 images you can use 50,000 images as to train a model, and 10,000 images are to test your model. And the shape of each image is 28 by 28 pixels. That means the total number of pixels used to represent an image are 784 images. So here the general process is this. So first you need to pre-process the data, so we can consider that as a 0th step. So once your data is pre-processed, then you need to define a model. So defining model is nothing but defining the sequence of layers. So once the model is defined, you need to compile. So while compiling, you need to specify the last function, and then what is the optimizer used. And then fitting data means model will learn from the trained data. Once the model is learned, you can use some new data or test data to make the predictions. So these are the steps that we are going to define. And let me just restart my kernel. So this data is a part of keras, so we no need to have a separate data set. So from keras.dataset importing mnist. So basically this is a class, and when you create an object to that, and it is having some the functionalities to download the data, right? So creating object to the mnist, no, nothing but getting the data. So importing the class mnist from the module keras.datasets, and our model is going to be sequential, means the model is defined in sequence of steps, layers. And these are the other layers. Dense layer, nothing but fully connected layer, which gives the output. And you have dropout, so you can drop some 20% or 30% or 50% of outliers. And once the dropout is applied, you need to flatten the data. And this is pooling layer. As I mentioned, there are three important layers: convolutional, pooling, and fully connected layer, also known as dense layer. So pooling layer, max pooling, and then convolutional, two-dimensional. And you need to use optimizer. So Adam is one of the optimizer. The use of optimizer is it try to improve the performance of your model at each iteration. And importing keras as a backend, then you have 10 classes. So by default the data is assumed as a single class. So in order to convert that into 10 classes, we have to use this two categorical, which is imported from tensorflow.keras.utils. I'm importing matplotlib to do the data visualizations, or to plot the images. So these are the libraries to be imported. And next so once the libraries are imported, we just download the data. So mnist.load data. So load data is the predefined method. We'll be loading the data, and the data is split into four parts: xtrain, ytrain, xtest, ytest. And we can also check the shape of the data. So we have 60,000 images in the train, not 50,000. So 60,000 images for training and 10,000 images for testing. So these 60,000, nothing but the number of images, total images, and shape of each image is 28 by 28 pixels. And this is a target variable ytrain, which is single dimensional. And we can randomly pick up some image, and we can show the image by using the matplotlib. So plt.imshow image show, and we are giving the 0th image from the xtrain. So what is this digit? So this is the digit 5. You can give any number over here. For example, I want the second image, which is 0. The second image is 0, like this. If you look at the image number 5, which is 2, so this is 2. After loading the data, you need to pre-process. So keras use this format. n width, height, depth. So the normal shape of the data is like this: the number of images, width, height, as we have seen in the previous cell. So we have to convert this into this format. So that is why, so xtrain is equals to xtrain dot reshaping the data. This xtrain dot shape of 0 means 60,000 images, then 28 width, height, then depth is 1. We consider black and white. Similarly for x test, and we are also creating a variable input shape, and the shape of each image is defined as 28 by 28 by 1, and then we are printing the shape of the data. So we have 60,000, then here 28, 28, 1. This is x train, this is x test. So 10,000 images are there in the test data, and we need to convert the pixel values to float. So converting and dividing by 255. So this puts the pixel values in the range of 0 to 1 after dividing the pixel values. Then we are checking the shape of y train. When you check the shape of one y train, so it is assumed as single class and 60,000 images are there. But as I mentioned before, we have totally 10 classes, 0 to 9. So we have to use two categorical, and y train, the number of classes we are giving as 10. Then y train and x test are converted into 10 classes. Now again we are checking the shape. So now we have 10 classes. So have a look over the cell number 9 and also cell number 10. So in cell number it is considered as single class, whereas in cell number 10, 11, so we have 10 classes. So once the data is pre-processed, the first step is defining the model. So specifying the batch size 128, that means at a time 128 images are fitted, and the number of epochs means iterations are 5. Then what is the architecture of your model? So model is sequential. So our model is sequential, that means the layers can be added in sequence. And at first we are adding the convolutional 2-dimensional, and the number of neurons are 32. The kernel size 3 by 3. Activation function is ReLU, and input shape equals to input shape. We have already defined in the previous cell. Again we are applying the convolutional layer. This time the number of layers are number of neurons are increased. 64, 3 by 3 kernel size. Activation function is ReLU. And next adding 20% dropout. Before that, max pooling, downsampling the image to 2 by 2. 25% dropout, flattening the data, then having the intermediate output 256 using the dense function, dense layer, and the activation function is ReLU. Then 50% dropout, and then the dense layer, and finally it gives number of classes. How many are there? 10 classes. So it is a 10 class classification problem, and here activation function is softmax. So in the middle, activation function is ReLU, but at the last you need to use the softmax for multi-class classification. So the model is defined. Next you can get the summary of your model. So the summary gives what are the layers and the input parameters. So these are the layers: convolutional 2 times, then max pooling, then dropout, then flattening, then dense, again dense, again dense. So this is the summary of the model. Next after the model is defined, you need to compile. So while compiling, you need to specify three important things. What is your last function? So last function is categorical keras entropy. Then what is your optimizer? Optimizer is Adam. And how do you evaluate your model? So by using the accuracy, because it's a classification problem. Then data, we want to fit the data to the model. So x train, y train, the model will learn from x train, y train. Batch size we have already mentioned 128. The epochs 5, and verbose 1 means it shows you what is happening in the background. And validation data used to evaluate your model is x test, y test. Then it says model has successfully trained, and you are also saving the model, and it also displays the message saving the model as mnast.h5. Now look at this output. So in epoch 1, so initially the loss is high, and the accuracy will increase. So there is an inverse relationship between the loss and accuracy. So loss is decreased and accuracy is increased. So this will take a couple of minutes. So estimated time is 2.26 something. So let's wait. So after completing all the epochs, you can see the loss is decreased from 0.20 to 0.03, and the accuracy is increased from 93 to 98. So this is training accuracy, this is validation loss, and this is validation accuracy. So if you compare the differences of training accuracy and validation accuracy, there is less difference. Otherwise, we'll say this is overfitting. So the model is pretty good because the accuracy is 99.12. You can say this. We can get the score. So model dot evaluate of x test, y test, and we can make a note of the accuracy by using score of 0 and score of 1. So test loss is 0.02 and test accuracy is 99.11, approximately 12. And we can show this by using the matplotlib graphs. So showing the training loss and validation loss in the first graph, and showing training accuracy and validation accuracy in the second graph. So loss is always decreased. So you can see that by using the loss graph here. So training loss and validation loss has been decreased, and how about the accuracy increases. So training loss and training accuracy and validation accuracies are increased. So we can make the predictions. So model dot predict of x test, making the prediction for x test and reshaping this x test to the shape of the number of images 28 by 28, and we would like to plot the images 4 by 4. So 4 rows, 4 columns. The figure size is 12 by 14, and showing the images from the x test and also showing the predicted values. So by using this graph, you can see the actual and predicted value. If there is a difference, then misclassification. Right, so you can see the output. The real is 7 and predicted is 7, so no difference. So correct predictions. Here also correct predictions. Correct. I think all of these are correct predictions only because the accuracy of the model is pretty good, 99.12. So there are no mistakes. So the model is built, and we can take up some new image. So by using the OpenCV, so I have some image digit9.jpg showing the image. So this is the image, and we need to check the shape of the image. So shape is this, which is not mapping with the shape of the model. So then convert the color. So by default the image is in BGR format. So converting from BGR to gray and resizing the image to 28 by 28 because the shape of our model is 28 by 28, and after reshaping, checking the shape, so 28 by 28. Next we have saved the model and loading the model again. Loading the model by using the function keras.model.load model, then printing the shape of the model. So this is the shape, and then we use matplotlib and also numpy to convert the image into array. So image to array, then expanding the dimensions, and we use model to make the prediction. So model dot predict of x, then model will make the prediction for the test image, and it has predicted correctly. So the input image is 9, and the model has also predicted 9. So like this you can give any new image. And you can see the output. So this is the pretty good model, and we have seen how to build a image classification model by using convolutional neural networks. So for any kind of data set, you can work in a similar manner and try to build a powerful classification model. So that's it from me today. So if you have any queries, you can just comment on our video, and do like and subscribe video so that we'll be getting the videos in the near future. So thanks for watching.